Another example in the quadratic equation applications has to do with a geometric shape. In this case, we're talking about the side of a square, and we're talking about the areas of a square. So again, if I have a square, the thing that's special about a square is that the side lengths are the same. So if this is x and this is x, the area is going to be those two sides multiplied together, which is x squared. And that's going to be the basis for this particular problem. So in this particular case, you actually have two squares. You have the length of each side of a square is 3 more than the length of each side of the smaller square. So we have a smaller square, which we don't know how big it is, but we have a bigger square. So in the smaller square, we don't know how big each side is, so I'm going to call this side x and this side x. And this one, we don't know how big it is either, but we know how big it is in relationship to this one. So it says that the length of each side is 3 inches more than the length of the smaller square. So if this side is x, this side is x plus 3. And if this side is x, this side is x plus 3. So it says the sum of these areas is 65 inches squared. Well, we talked about the area of this one would be x times x, so the area of this one is x squared. And the area of this one is x plus 3 times x plus 3. So if we think of it like we usually write it, x times x is going to give me x squared. This is going to give me 3x. This is going to give me 3x. This is going to give me 9. So I'm going to add up my two areas. So inside this square, I have x squared. Inside this square, I have x squared plus 6x plus 9. And I know when I add those together, I'm going to get 65. So just like with all of our other quadratic equations, we are going to make this equal to 0. So I'm going to add the terms. I have 2x squared plus 6x. And I'm going to subtract the 65 to the other side. So when I take 9 minus 65, I get negative 56. So I have 2x squared plus 6x minus 56 is equal to 0. Again, if you're comfortable with factoring, feel free to factor. I'm going to use the quadratic formula. So I have x is equal to the opposite of b, which is negative 6. Plus or minus the square root of b squared, which is going to be 36, minus 4 times a, which in this case is 2, times c, which is negative 56, all divided by 2 times a, which is 4. And we take our calculator and do this part in here. We have 36 minus 4 times 2 times 56, negative 56. That gives us the square root of 484. And the square root of 484 is 22. So that gives us negative 6 plus or minus the square root, plus or minus 22. All over 4. So like we've seen before, that gives us negative 6 plus 22 over 4, or negative 6 minus 22 over 4. In this case again, negative 6 minus 22 is going to give us a negative number. We know our square can't be negative, so this is going to be not existent for this problem. And when I take negative 6 and I add 22, I get 16. Over 4, which means x is 4. The problem asks us to find the lengths of the two squares. So the smaller square is 4 by 4. And the larger square, remember, was this one plus 3. So the larger square is 7 by 7. And that is the solution to this geometric problem. Our last example of a quadratic application has to do with surface area of a cylinder. So if we remember a cylinder, that kind of looks like a pop can. looks something like this. And there's a formula for a cylinder that has to do with two circles that are on top and one that's on the bottom, and then the middle part if we open that up. The surface area for a cylinder is equal to 2 pi r squared. That's the two circles on top, so pi r squared is the area of the circle, so 2 pi r squared plus pi r h. Alright, sorry about that. The surface area is 2 pi r squared, that's the top and the bottom, plus 2 pi r h, where h is the height of this, and r would be the center out on the top and the bottom. So in this particular problem, it says a manufacturing firm wants to package its product in a cylinder container that is 3 feet high. So we know that this is 3 feet, with a surface area of 8 pi feet squared. So this part over here is 8 pi feet squared, and we were trying to solve what the radius is. So we're going to fill in the information that we know. So it says that the surface area is 8 pi, so we're going to write that over here. 8 pi is equal to 2 pi, we don't know what r is, so we're going to write that as r squared, plus 2 pi, we don't know what r is, but we do know what h is. H is 3. So this equation looks completely confusing because of the pi's in here. But notice it still has an r squared and it still has an r, and we can make this equal to 0. So I'm going to write this as 2 pi r squared plus 2 times 3 is 6, so that's 6 pi r minus 8 pi is equal to 0. Because if I subtract this to the other side, it'll be equal to 0. I can see that each of these terms have a pi in it, and each of them are actually divisible by the number 2 as well. So I'm going to take this term and divide it by 2 pi. I'm going to take this term and divide it by 2 pi. I'm going to take this term and divide it by 2 pi. And I have to take 0 and divide it by 2 pi. And when I do that, life is going to become a lot easier. So 2 pi divided by 2 pi just gives me r squared. 6 divided by 2 is 3. Pi divided by pi cancels, and I'm left with r. And negative 8 divided by 2 is 4. Pi over pi cancels, is equal to 0. Again, you can use a quadratic formula on this equation, or you can factor it. In this case, I'm going to factor because I know there are two numbers that multiply to give me negative 4 that also add to give me 3. Those two numbers are positive 4 and negative 1. So I know that this factors to be r plus 4, r minus 1. So that means my two answers must be r is equal to negative 4 or r is equal to 1. Again, I can't have a radius that's equal to negative 4, so this is not part of my answer, and my radius must be 1. And that's what the question is asking for, so that is my solution.